We're continuing our study in set theory by talking about its applications in Venn diagrams today. Take a look at example 1. Draw Venn diagrams and shade the regions representing each set. So here we have A prime intersected with B. So let's draw each of these out. So A prime means everything that is not in A. So that would be this. Okay, and then B, so that's everything inside of B. Now we're trying to find the intersection of these two shaded regions. The intersection of these two shaded regions would be everything that's in B and only in B. So that would be this shaded region right here, and that's how you would represent A prime intersected with B. Let's look at the next example. We have A prime union B prime. I'm going to do the same thing. I'm going to draw out what A prime looks like, shade that, B prime, and then we'll go ahead and find the union of those two. All right, so here's A prime. So A prime is everything that is not in A, shaded. And then B prime, that's everything that's not in B, shaded. Now the union of those two sets means I'm going to combine everything that's shaded in A prime and everything that's shaded in B prime. It looks like the only thing that's not shaded in either of those is the intersection of A and B. So if we are to find the union of these two sets, that would be everything other than the tiny little section in the middle that is going to be shaded. All right, example 2. Now we're going to step it up and put 3 sets in there to work with. So in a Venn diagram, shade the region that represents A prime union with B intersects C prime. Okay, so we're going to build up to this. We'll start with A prime. So A prime, we would shade everything that's not in A. Next, let's do B intersected with C prime. So B intersected with C prime means everything that's in B would be shaded, but we also want to intersect that with everything that's in C prime. Now what's in C prime? C prime is everything that's not in C. So we want to shade everything in B that is not in C. So that would be this section here. Now we need to combine these two with a union. So I'm going to take everything that's shaded in A prime and everything that's shaded in B intersects C prime, and I'm going to combine them together. So it looks like it's going to look almost the same as A prime, except that there's one tiny little section there that's also going to be shaded as well. So here's B intersected with C prime, and I'm going to combine that with A prime. So that is how you come up with that shaded region. Let's take a look at an example where we're actually working with some data. All right, a researcher collecting data on 100 households finds that 76 have a DVD player, 21 have a Blu-ray player, and 12 have both. Part A, how many do not have a DVD player? Part B, how many have neither a DVD player nor a Blu-ray player? And Part C, how many have a Blu-ray player but not a DVD player? Now, this can get a little bit confusing, so the best thing to do is to use a Venn diagram and represent this information. All right, so we have two things, either a DVD player or a Blu-ray player. People could also have both. Altogether, there are 100 households. Okay, so we know that 12 have both. Now, we can start there, but now we have to include other pieces of information. So let's say we start with the 76 have a DVD player. All right, if 76 altogether have a DVD player, but not just only a DVD player, we have to subtract out those 12 who do have both. So 76 minus 12 would give us 64. So there are 64 people who only have a DVD player. But notice when you take into account everything that's within that circle, within that set, if you add them together, you get the 76. We'll do the same thing with a Blu-ray player. So 21 have a Blu-ray player, but not just a Blu-ray player. So we are going to subtract out the 12 that have both. So 21 minus 12 leaves us with 9. So again, notice how now we've represented the people who have just a Blu-ray player, the people who have both, and you can still see altogether how many people have a Blu-ray player. Now we're told that this researcher collected data on 100 households altogether, so there are possibly some households that don't have either. Well, how many? Well, we know how many altogether have a DVD player, a Blu-ray player, or both. So now the 64, the 12, and the 9, if we subtract all of that from 100, that will leave us with the number of people who don't have either. So 100 minus 64 minus 12 minus 9 is going to give us 15. Now let's go ahead and answer the questions. So part A, how many do not have a DVD player? Well, how many don't have a DVD player? Well, it looks like the 9 who just have a Blu-ray player and the 15 who don't have either. So the 15 plus the 9 gives us 24. So there are 24 households that do not have a DVD player. Okay, how many have neither a DVD player nor a Blu-ray player? Well, we know from our diagram here that when we subtracted everything from 100, we ended up with the 15. So there are 15 that don't have either. All right, part C, how many have a Blu-ray player but not a DVD player? So these are the number of people who only have a Blu-ray player. So that would be the 9 that are just in the Blu-ray circle and not in the DVD circle. So that would be 9. Now, if you prefer to not have to draw this out, there is what we call a union rule that works when we're just talking about numbers that you're given and you're talking about the union of sets. So the number of elements that are in A union B is equal to the number of elements in A plus the number of elements in B minus the number of elements that are in both A and B. Now, why is this true? Well, think about when you are taking the union of two sets, you're trying to combine it, you end up with these repeats, right? Because there are some things that are just in A, some things that are just in B, but then there are some things that are in both A and B. Now, if there are things that are in both A and B, you don't want to simply add the elements in A plus the number of elements in B to get the total number of elements, because now you've double counted. So what we're going to do is we're going to subtract out the things we double counted. The things that are double counted are the ones that are in both A and B. So that's why you would subtract the number of elements in both A and B. So take a look at example 4. A group of 10 students meet to plan a school function. All are majoring in accounting or economics or both. 5 of the students are economics majors and 7 are majors in accounting. How many major in both subjects? Okay, so in this case, we're going to use that union rule, but not to find A union B, but to find the number of elements that are in A intersect B. How many are majoring in both A and B? So let's start off by writing out that rule. Now we're going to call the ones who are economics majors set A, the ones who are accounting majors set B. Now we know that there are a group of 10 students altogether. So A union B, the number of elements, is 10. So this is going to be 10 equals 5 plus 7 minus the number that are the intersection of both. So minus the number who are majoring in both economics and accounting. All right, now to find that number, all we have to do is get that by itself. We can go ahead and subtract that 12 from both sides. We get -2, which really just means that the number of elements that are in both A and B is going to be 2. Now you can check to make sure that that works. You can absolutely draw this out in a Venn diagram, and you would see that, well, if 5 of them are economics majors, 7 are accounting majors, but there are only 10 of them, that must mean that 2 of them are majoring in both. There are 2 of them that overlap within those sets. All right, take a look at example 5, a more complex Venn diagram. Suppose that a group of 150 students have done at least one of these activities online: purchasing an item, banking, and watching a video. In addition, 90 students have made an online purchase, 50 students have banked online, 70 students have watched an online video. Now that's in general. It doesn't mean that they've only done that one. 15 students have made an online purchase and watched an online video, 12 have banked online and watched an online video, and 10 students have done all 3. Now, how many students have made an online purchase and banked online? All right, so let's go ahead and put this all into a Venn diagram. So there are 3 types of online activities that we're tracking. So purchasing, banking, or watching a video. So I'm going to make those 3 circles represent those 3 things. Now let's start with the information that we already have. I like to start with the information where there's the most overlap. So we know that there are 10 students who have done all 3 of these. So I'm going to start off by putting 10 right in the middle. Okay. Now we know that there are 12 that have banked online and watched an online video. Well, what does that mean? That means that altogether in that overlap between banking and watching a video, there should be only 12 students. Now 10 have already been accounted for because they've done all 3. So what's left is just 2 that have only done online banking and watched a video. Next, we have 15 students that have made an online purchase and watched an online video. So since 10 are already accounted for, there are going to be 5 that have only made an online purchase and watched an online video and have not done the banking. So we'll put the 5 there. Now to finish filling out these smaller chunks here, we want to know how many students have only purchased something online and done online banking without having watched a video. Now we don't have that information, so we're going to call this X. And then we'll fill in the rest from there. Now we're told that 70 students have watched an online video. Now since 70 students have watched an online video, and we already have 5, 10, and 2 that are accounted for here, we have to subtract out the 5, the 10, and the 2 to get the remaining students who have only watched an online video. So 70 minus 10 minus 5 minus 2, that gives me 53. All right, let's continue. 50 students have banked online. So we'll do the same thing as what we just did here, but since we have X in there, we're going to have to write our expression in terms of X. So since we know there are 50 altogether, and 2 and 10 are accounted for, and also X, we just don't know what X is, we can write this as 50 minus that X minus the 10 minus the 2, so minus 12. So 50 minus X minus 12. Do the same thing for those who have made an online purchase. We know altogether there are 90, and we know that there are 10, 5, and X that are already accounted for. So we do 90 minus the X minus the 15 others. All right, now that we've made a Venn diagram, we want to go ahead and use that Venn diagram to help us actually answer the question. So how many students have made an online purchase and banked online? Well, we need to know how many did only the online purchase and banking and not watching the video. So what we're going to do is we're going to take all the information from the Venn diagram, and now remember we were told that 150 students are part of this survey. So what we're going to do is we're going to take everything that's currently on the Venn diagram, add them together, and we know that should equal 150. So we'll take the 90 minus x minus 15 plus the x plus 50 minus x minus 12 plus 10 plus 5 plus 2 plus 53, and that should all equal 150. Now we can go ahead and simplify this, so it looks like a minus x and a plus x will cancel. We'll put together all the numerical values that we have, so 90 minus 15 plus 50 minus 12 plus 10 plus 5 plus 2 plus 53. We end up with 183 minus x is equal to 150. Now we're getting x by itself, so I subtract 183 from both sides. That leaves me with negative x equals negative 33, which means x is equal to 33. Now the question, how many students have made an online purchase and banked online? Now it doesn't say have only done the online purchase and banking online, so that means that it must also include the ones who have also watched a video. So going back to our Venn diagram, we can now fill this back in and say this is 33, and what it's asking for is this shaded region here. So 33 plus the 10, so altogether there are 43 students who have made an online purchase and banked online. So you can see how the Venn diagram helps us organize information. It helps us categorize different things so that, for example, in this particular case, we were able to differentiate from the students who had done certain things but had not done other things online. In this case, we were able to summarize how many students have made an online purchase and banked online, but we were also able to separate it so that we knew how many only did those and how many had also watched a video as well. And so you can see how useful Venn diagrams can be in organizing information for us.